Next, we have a keynote by Erik van Winkle, who will be talking about decentralized science. For those that don't know, DeSci is a platform that seeks to offer more fairness and transparency in peer reviews by rewarding good and fast peer reviews to increase the quality and productivity of academic research. Erik is the head of operations at DeSci Labs and a Georgia Tech alum. Please join me in welcoming Erik to the stage.
Awesome. Hi, everyone. Glad to have you here, and I'm excited to talk a little bit more about decentralized science. So my name is Erik van Winkle. I work for a group called DeSci Labs, and we are trying to make reproducibility and replicability the center of quality science. Now, just to start off with, can I get a quick show of hands? Who all in the audience is an academic in some way, shape, or form? Professor, postdoc, researcher, industry or not? Awesome. Well, I appreciate y'all coming to this. So, want to go ahead and start out by saying to anyone who's in more the Web3 space, I am going to use some more academic terminology, and will do my best to put that into layman's terms. To anyone who is a researcher, I understand that you may or may not have skepticism around Web3, the monkey coins, the doggy pictures, I get it. But this is incredibly powerful technology that can do a lot of good in remaking the back end of scientific research. What we're trying to make is an application that is focused on end users themselves, and not necessarily the fact that it uses crypto. So with that being said, I want to start out by talking to some of the folks who may not be academics about a problem in science called the replication crisis. So for a paper to replicate, what that means is that you have to take the methods section from that paper as a separate researcher, and let's say 5 years later, on the other side of the world, completely recreate that study. You collect your own data based on what they said to do. You analyze the data based on what was said in the paper. You may even completely rewrite the code yourself. And what that means is that your science has been verified as true knowledge that can be repeated over and over and over again. Now, we're currently dealing with something in science called the replication crisis. About 90% of cancer studies don't replicate. And this is a problem, because if you think of a scientific paper, the bottom 2 to 3 pages is normally citations, 40, 50 of them. And if 37 of those 40 papers do not replicate, and each one of those has 40 more citations under it, where 37 of them don't replicate, you run into problems. You run into foundational uncertainty in the systems of science themselves, where as a researcher, your work may be flawed based on no fault of your own. This is a massive issue in scientific research, and there are a lot of reasons why the replication crisis is happening. But one of the bigger ones is the fact that scientific infrastructure is built on technology from the 1990s. The last major technological innovation in the field of science was when the PDF first came out. It is a massive problem, but if you want to go about solving the replication crisis, one of the first things that you can do is incentivizing and allowing scientists to share the entirety of a piece of research, not necessarily just the final 20-page PDF itself. So I'm going to talk to you about 3 different products today. I'm going to show you one example of how Web3 can be used to make better systems of science. So these 3 products are DeSci Nodes, DeCite, and DeSci.fetch. The first one, DeSci Nodes, I'm actually going to give you a live demo of on stage. So for starters, let me just go ahead and refresh the page so we're back at the right spot. When you log on to any scientific paper, the first thing that you're going to see is the PDF itself. And that is what's visible here. But I think what's important is the fact that the entirety of a piece of knowledge can be aggregated in one place. So if you click on this little side menu over here, you see an entire navigation pane. And the first thing that I want to point out in this navigation pane is the components section. So with the research report as the first component, you can additionally put a reproducible code docker running Python notebooks, one click away from the research report itself on the same pane without having to navigate off of the website. You can add supplementary materials, PDFs, code, even data files that can be pulled directly off of online repositories can all be located in the same spot. This goes for videos, for pictures, for anything else that you can possibly imagine that was a part of the intellectual provenance needed to make that piece of research. Now, this is important, but there are a couple other aspects that we've built into this system. One of the things that I think is particularly interesting is the concept of a version history. So if you publish a paper, let's say at the very end, you get your 20-page summary, your massive PDF. But realistically, you didn't start out with the 20-page summary. It was 3 to 4 years of your life spent researching this particular concept. You started out with a hypothesis. Then maybe you had, let's say, a grant application or a pre-registered analysis plan, whatever it was. Your piece of research slowly grew over time to be this final state piece of knowledge. All of that can be seen through integrated version histories on the application itself. So you can go back and click to what the piece of knowledge was, let's say 3 years ago, and see the complete chain of intellectual provenance as it's grown. There are other aspects that we're building into the system, like validation marketplaces, attributes similar to what you would see in an ACM or OSF conference, but I won't go into all of that just now. The other aspect that I want to hit on, I guess 2 more, is the concept of annotations on top of a PDF, because realistically, we can do so much more than a base PDF in 2020. So you can add nice comments around, maybe this is an assumption that was made in the paper that needs to be called out. But maybe on top of a figure itself, you want to annotate the exact code file that was used to make that paper, so that if someone wants to see the file itself, it's one click away, the integrated code and data files with a little blue button down here for one-click reproducibility. All of these different components that comprise a piece of knowledge linked together on one single pane of glass for one-click reproducibility. That is essentially what DeSci Nodes is. We also have aspects around fair data. I can go on and on. But I think what's more important is going back to the slideshow and talking a little bit about other aspects that complement this system. So I said in this first slide, I was going to talk about DeSci Nodes, which is what we just saw the demo of, DeCite, and DeSci.fetch. So let's quickly go to DeCite. DeCite is a decentralized citation registry protocol for research objects that enables friendly, short URLs, which look exactly like a DOI, but can reference anything in a research object itself. So let's say your research object can contain 4 different versions, that it contained a wide variety of components actually listed there. Any and all of that can be cited through this DeCite URL schema, and all of the citations for that aggregate back to one single point. Right now, as a scientist, if you publish the entirety of your research and you have that research fragmented, your citation counts will fragment as well. Your H-index is going to be hurt. In this model, the entirety of your citations aggregate back to one single point, which is a really interesting example of how emerging technology can be used to rethink the underlying incentive structures behind science itself. And it's not just better technology for the sake of technology, it's thinking about cultural and social norms in academia and how technology can be used to help shift some of those. So this is one example of how that can be done. The other thing that I want to talk about is DeSci.fetch, which is a Python library that we've created that allows anyone to import information directly off of the scientific ledger of record. So our application, really and truly, the only thing that we are holding, the only thing that we are monetizing is the front end itself. The back end, all of our code, all of the data that gets collected on this is open. We are not creating data silos. It is an open state repository, an open global dataverse, which means that all of this information can be queryable. If it's organized correctly in accordance with FAIR principles, we can create a machine-readable ledger of record that can be queried indefinitely from someone's integrated development environment, from whatever you prefer to use to interact with Python itself. So DeSci.fetch is how we're going about making that happen. One of the really cool things to mention about this is every time someone imports a piece of your code, a piece of your data, the text from your PDF, that's a citation. That's a count that gets aggregated. That's an additional metric that can be used to map impact more efficiently across systems of science. Once again, it's not just about technology for the sake of technology. It's about technology to try and solve problems in the system that you're working in. So just to summarize all of this, interoperable research objects, completely aggregating PDFs, code, data, videos, pictures, whatever you want, linked together for one-click reproducibility with on-chain version histories. I didn't even really get into the open science badging and attributes, the AI-generated cover art for every paper that gets put on the platform, citations as function calls. There's so much that can be done with new technology if we're willing to sit down, to think about it, and to build it. So, taking a step back, DeSci Labs is one group in a growing decentralized science space. There are probably 100 others that have popped up over the course of this past year. It is growing at a rate that I physically cannot keep track of. Whether we're talking about actual researchers performing in DAO models, we're talking about on-chain tokenized intellectual property, we can be talking about Reddit-style publishing forums. A wide variety of experiments and concepts are popping up and dying off faster than anyone can keep track with them, and it's incredible and exhilarating. So I want to talk about one other group in the space, who we partner with very closely and who actually presented at Web3 ATL, Bakal. Wes Floyd, if you saw his IPFS talk, great guy. So I'll quickly give a story. Big data is challenging. For the gravitational waves experiment, it was more cost efficient and it was faster to charter a Boeing 747, load 700 terabytes worth of hard drives into said airplane and fly it around the world than it was to put it on AWS and have all of the data go in and all of the data come back out. You're paying for data on both ends, data transfer on both ends, long-term data storage. Might as well just charter a 747. We can do a lot better than that. Decentralized storage protocols create marketplaces that essentially race to the bottom on storage costs themselves. We can solve the cost problem. But the speed problem is still a challenge, which is where Project Bakal comes in. They're doing something called compute over data, which data storage in Web3 can be fairly complicated along peer networks. So computing on top of that, very difficult. But they've enabled a way for computation to be done right where the data lives, as opposed to having to transfer data back in and out on a wide variety of hardware that anyone can go about actually being a node for. So this is interesting because it's a way that we can enable one-click reproducibility on massive data sets. Bakal is essentially, or it will become, a supercomputer at your fingertips. IPFS is a cheap back-end storage solution. All of that can be tied back into this front interface for one-click reproducibility on massive data sets, where not only in this code docker can you click the run button, you can play around with someone else's parameters. You can change the underlying code that was used to make a graph in your research for your paper itself and actually use that. Bakal can be integrated to Python libraries, really doesn't matter, whatever it is. So what I came here to say, is that there is an entire space of innovation at the intersection of blockchain and academia that is absolutely phenomenal. It's an exciting place to be. It's growing fast. There are very interesting concepts coming out of it. And I would encourage anyone who is interested to come join the conversation. One other thing to mention before I close out, we're not making data silos. All of this data, we would love for it to be the entirety of humanity's scientific knowledge. We'll live on an open state repository. We're not holding any of that hostage. Anyone can come develop on that data repository itself. So if you are an open source developer, or I guess a corporate developer who is actively interested in making a difference in the world, you want to help solve climate change, come help build a better backend for the people who have dedicated their lives to climate change research. This is a direct pathway with a consolidated data repository that is cleaned and usable and will only continue to grow. Come help us build on top of that. We would love for you to be there with us. And to anyone else who's interested, I'll be over there, I guess, in the back room after this conference, more than happy to talk about what's being built. So with all that being said, do I have time for questions? I have 5 minutes. Does anyone have any? Yeah?
Yes, it's actually really exciting, like on the Oracle side.
That's an incredible point. And for anyone who wasn't able to hear, a lot of the question/comment was around the use in scientific data for oracles and how this can go about helping bring trustworthy information on chain. One of the things that I'm incredibly passionate about with respect to this actually kind of plays off of that concept in terms of the trustworthiness of scientific data. It's painful to watch the way that the general public and academia interact with each other. At best, we tolerate science, and at worst, we actively reject it. And a part of that is because the trustlessness isn't necessarily there. There are so many questions that appear, and I can't tell you how many YouTube videos I've watched where someone says, oh, well, this study said, and then you go look at the study, and it's a preprint from like 7 years ago that was since redacted, but because the underlying systems of science are terrible, that redaction has never officially made its way through all of academia. I would love to see time-stamped data provenance, which can allow for trustworthy sources of information flowing directly into Chainlink oracles themselves. Yes, absolutely. Just the concept of this open state data repository has endless, limitless possibilities, essentially, for anyone who wants to come build on it. Could not agree more. I've got one more question in me. Yeah. So we very closely adhere to something called FAIR data compliance. And FAIR stands for findable, accessible, interoperable, reusable, which is what the scientific record should be. In FAIR data, essentially what they say around, let's say, a piece of data getting removed, is that it's totally fine for the data to be removed. Let's say it was a study with human subjects in it. That should be private data. What you need is a metadata pointer to that object to say that either it is there or it was there, whatever it needs to be, and here's how you go about accessing it. This is who you need to talk to. Here are the identity requirements that are needed from there. It's not that all of the data has to be open, but it's that it needs to be findable and accessible at the very least. Does that answer the question?
So as a research team, do I set up those provisions?
We haven't built that part yet, but you will have to go about setting this up. Part of what we have built out of the box is this full FAIR data compliance. And I could see a system in the future where based on specific licensing types, it adds another aspect before you're allowed to publish, which details out access requirements themselves. Data compliance and access is a very tricky and complicated problem with a million different iterations for solutions. All right, this is my last question. The onboarding process, we're in open beta starting in December, so we would love for people to come try it out.
We have a pretty good, in my opinion, first mile flow for someone to get onboarded. One of our main focuses in building this product was UI UX, because that is one of the most critical parts of onboarding into a tool itself. And it's also a massive OPSEC concern, which I don't think people talk about UI UX as an OPSEC concern often enough. But yeah, so it really is just log on. You can log on with your email, Facebook login, Gmail. We use Taurus as a web wallet. So yeah, that's pretty much the gist of it. But I am out of time. If you have more questions, I'll be out in the back room. Thank you, everyone.